హలో ఫ్రెండ్స్, హాయ్. ఈ వీడియోలో మీకు ఇంటిగ్రల్ ఈక్వేషన్స్ స్ట్రక్చర్ ఎలా ఉండబోతుంది, వాల్టెరా ఇంటిగ్రల్ ఈక్వేషన్ అండ్ ఫ్రెడల్హోమ్ ఇంటిగ్రల్ ఈక్వేషన్స్ డెఫినేషన్స్ అండ్ సమ్ ప్రాబ్లమ్స్ ఆఫ్ వాల్టెరా ఇంటిగ్రల్ ఈక్వేషన్స్ గురించి మీకు డీటెయిల్గా ఎక్స్ప్లెయిన్ చేస్తాను. నౌ వాట్ ఈస్ ద ఇంటిగ్రల్ ఈక్వేషన్? So, an integral equation is nothing but an equation which is one unknown function appears under the integral sign. An integral equation is nothing but an equation in which one unknown function appears under the integral sign. Suppose I am taking pi of x is equal to 6x minus 5 plus 0 to x minus I whole square into pi of z dz. It is one integral equation because here this function pi is an unknown function. This function pi is an unknown function. So this is called as an integral equation. This function 6x minus 5, this function x minus I whole square, these are the known functions. It is also known function. These two are known function. This is unknown function. This pi is unknown function. So we call this is the integral equation. Now come to second example. Pi of x is equal to f of x plus lambda times of integral 0 to some b, some x, not p, some x, k times of x xi pi of z dz. It is also another integral equation. Here k of xi, f of x are the known function. These two are the known function which is given in the problem, but pi is not given, so this is called as a integral equation. F and k, these two are known function. This is unknown function, so we call this is a integral equation. Next, now what is integro-differential equation? Integro-differential equation means, so pi of x is equal to x square plus 0 to x 2 times of x minus xi pi of xi into pi dash xi. So see this example, in which integral equation after under the integral sign pi of xi and its derivative is pi dash xi. The derivative of a unknown function appears in an integral sign, so which is called as a integro-differential equation. So dear students, you observe what is integro-differential equation. Integro-differential equation means an integral equation in which an unknown function and its derivatives appears under the integral sign. Unknown function pi and its derivative is pi dash appear under the integral sign, we call as a integro-differential equation. Next one is linear integral equation. Linear integral equation means, see first this example, pi of x is equal to 1 plus 2 times of 0 to x 2 times of x minus I whole square into pi of xi. The unknown function pi of xi power is 1. So the power of unknown function in a integral sign is 1. That integral equation is called as a linear integral equation. You see the unknown function pi whose power is 1, so this is called as a linear integral equation. If power of this unknown function is not 1, that means any positive integer greater than or equal to 2, that equation is called as a non-linear integral equation. See this example for non-linear differential equation. Pi of x is equal to 1 plus 2 times of 0 to x 3x minus 2 xi whole square pi of xi whole power 2. Here you see the power of pi of xi is 2, means the power of pi is greater than or equal to 2, that must be a positive integer, so this is called as a non-linear integro-differential equation. If you take pi of xi whole power 3, pi of xi whole power 4, these are all the non-linear integral equation. So pi of x is equal to 1 plus, here 1, it is f of x is equal to 1, it is known function. This what kernel is what is the kernel of this function? K of xi is equal to 3x minus 2 xi whole square. So these two are known functions. This is unknown function whose power is not 1, means any positive integer greater than or equal to 2, then this equation is called as a non-linear integral equation. Next, the important concept for integral equation is general form of the linear integral equation. This is the structure of general form of the linear integral equation. So alpha x into pi of x plus is equal to f of x plus lambda times of k x xi pi of z d xi, where the range of the function is, range of the integral is here wedge. Any range of the integration is wedge I am taking here. This is called as a general form of a linear integral equation, where look here, the function pi is unknown function. The function pi is a unknown function here. Here this function is unknown function. Alpha x, f of x, k of x xi are known functions. These three are known functions. This wedge is the range of the integration. Integration limits. This function is the range of the integration. So this is called as a most general form of a linear integral equation. Here k of xi is called as kernel. Kernel of integral equation. Kernel of integral equation. This is a known function. Here k of xi is called as a kernel of integral equation, which is a known function. Now the integral equations are, here we discussed in two types particularly. One is Volterra integral equations, second one is Fredholm integral equation. Now first I am defining what is Volterra integral equation. An integral equation is said to be a Volterra integral equation if upper limits of integration is variables. An integral equation is said to be a Volterra integral equation if its upper limits, actually in this previous general form of the integral equation, the upper limit must be is variable. That equation is called as a Volterra integral equation. So this is a to x. So alpha x into pi of x is equal to f of x plus lambda times of a to x k of xi pi of xi d xi. So whatever the lower limit, so upper limit must be, upper limit of integrations is variables. If upper limits of integration is variables, so its structure of Volterra integral equation is this form. Alpha x into pi of x is equal to f of x plus lambda times of a to x k of xi pi of xi d xi. The upper limit x, almost the lower limit must be a constant, and the upper limit x, this is must be variable. Then this integral equation is called as a Fredholm integral equation. The most general form of the Fredholm integral equation is alpha x into pi of x is equal to f of x plus lambda times of a to x k of xi pi of xi d xi. Now I am going to define what is Volterra integral equation of first kind, second kind, and homogeneous Volterra integral equations. Now I am giving these three definitions. So in this integral equation, if this alpha x is equal to 0, if alpha x is equal to 0 in this integral equation 2, in equation 2, this becomes what? 0 is equal to f of x plus lambda times of integral a to x k of x xi pi xi d xi. This is called as a Volterra integral equation of first kind. It is also denoted by, this is equal to f of x is equal to lambda times of integral a to x k of x xi pi xi d xi. This is called as a Volterra integral equation of first kind. Whenever the upper limits is a variable, this is a Volterra integral equation. Alpha x is equal to 0. If alpha x is equal to 0 in equation 2, put alpha x is equal to 0 in equation 2, we get this is equal to like this. This equation becomes like this. This is called as a Volterra integral equation of first kind. If I am taking alpha x is equal to 1 in equation 2, if alpha x is equal to 1 in equation 2, then we get what? Pi of x is equal to f of x plus lambda times of a to x k x xi pi xi d xi. So this equation is called Volterra integral equation of second kind. Here f of x and k of xi are the known functions, pi is unknown function. The range of the limits of the integration a to x, upper limit must be a variable, so we call as Volterra integral equation of first kind. Now I want to discuss for homogeneous Volterra integral equation. In which homogeneous Volterra integral equation alpha x is equal to 1, then this function f of x must be equal to 0. Alpha x is equal to 1, f of x is equal to 0, then equation 2 becomes then equation 2 becomes pi of x is equal to, this is 0 plus lambda times of integral a to x k of x xi pi xi d xi. So that means what? Pi of x is equal to lambda times of a to x k of x xi pi xi d xi. This is called as Volterra integral equation of homogeneous Volterra integral equation. So these are the brief information about that Volterra integral equation. This is the general form of the Volterra integral equation. In this general form, alpha x is equal to 0. This equation is called as Volterra integral equation of first kind. Alpha x is equal to 1. This integral equation is called Volterra integral equation of second kind. If alpha x is equal to 1 and f of x is equal to 0, this equation is called homogeneous Fredholm integral equation. These are the classification of Volterra integral equation. Dear students, you remember once again, when the Volterra integral equation, the limits, upper limit must be variable. Now Fredholm integral equation. Fredholm integral equation. Now what is Fredholm integral equation? An integral equation is said to be a Fredholm integral equation if both upper and lower limits of integration are fixed, means real numbers. Both lower and upper limits of integration is real numbers. That integral equation is called as a Fredholm integral equation. The most general form of Fredholm integral equation is alpha x into pi of x is equal to f of x plus lambda times of integral. Both lower and upper limits are fixed real numbers, k of x xi pi xi d xi. This is the Fredholm integral equation. General form of the Fredholm integral equation is this one. Now this can be classified into three, means what is first kind of Fredholm integral equation, what is second kind of Fredholm integration, what is homogeneous Fredholm integral equation. Look my dear students, if alpha x becomes 0, if alpha x is equal to 0, then equation, suppose I am giving this is equation 3, then equation 3 becomes, whenever this becomes 0, left hand side must be equal to 0, only we get f of x plus lambda times of integral a to b k of x xi pi xi d xi is equal to 0. That means it is also written as f of x is equal to, because of minus lambda, means again it is a lambda is a constant, for that time can write is lambda times of a to b k of x xi pi xi d xi. So this is called as a Fredholm integral equation of first kind. In case alpha x is equal to 1, then equation 2 becomes, whenever this alpha x is equal to 1, equation 2 becomes pi of x is equal to f of x plus lambda times of integral a to b k of x xi pi xi d xi. This is called as Fredholm integral equation of second kind. Okay. Then third one is if alpha x is equal to 1, f of x, the known function f of x, this function f of x must be equal to 0. This value is equal to 1, this value is equal to 0. Then the general form of Fredholm integral equation becomes, the structure of this one is equal to pi of x is equal to lambda times of integral a to b k of x xi pi xi d xi. This is called as homogeneous Fredholm integral equations. So these are the three classification of Fredholm integral equations. Now actually in this unit, in the chapter, we are going to study Volterra integral equations, details study of Volterra integral equation. Now the definition of singular integral equation. Now what is singular integral equation? That means an integral equation is said to be a singular integral equation if one or both limits of the integrations becomes infinity. The limits of the integration becomes infinity, or the kernel of the integral, either limits of the integration is both are infinity, or kernel becomes an infinity at one or more points within the region of the integration. This kernel becomes infinity if one or more points within the range of the integration. Means what? Suppose you see here. So first example, pi of x is equal to f of x plus lambda times of this one. Here lower and upper limits both are infinity, so this is called as a singular integral equation. Now see second example, f of x plus a to x x minus xi whole power minus 1 by 2 pi of z dz. Both the limits are not infinity. So whenever the integration with respect to xi, these are the limits belongs to xi, so that a less than or equal to x less than xi less than or equal to x. That means xi lies between this one. So this is the region of the integration. Xi belongs to a to x. Xi belongs to a to x. So what is the kernel here? Kernel is equal to k of xi is equal to x minus xi whole power minus 1 by 2. That means 1 by root of x minus xi. So the range of the integration, xi takes either a or x between the values. Suppose if I want to take xi is equal to x, if I want to take xi is equal to x, what happens here? 1 by x minus x. Something is, this is 0, 1 by root 0, that means 1 by root of 0, 1 by 0 means this means infinity. So this becomes infinity. So kernel becomes infinity at one point xi is equal to x in the region of the integration, so that this is called as a singular integral equation. This is singular integral equation. This is also singular integral equation. Singular integral equation means in an integral equation either both limits of the integrations are infinity, or the kernel becomes an infinity between the region of the integration. Between the region of the integration at one point or more than one points, this becomes infinity. That integral equation is called as a singular integral equation. Now I am studying how to solve the Volterra integral equations. Now verify whether the given function pi of x is the solution of the corresponding Volterra integral equation. Pi of x is equal to 3, x cube is equal to 0 to x x minus xi whole square into pi of z dz. So here given that this is an integral equation, now we are going to verify pi of x is equal to 3, the unknown variable function. Pi of x is a constant function which is the solution of the given integral equation. Already we know that in a differential equation, when the differential equation is given, we are going to find the solution of a differential equation. Here also the integral equation is given, pi of x is equal to 3 with unknown function. Now we are going to check this pi of x is equal to 3 whether it is a solution or not for the given integral equation. For that I am substituting the function pi of x is equal to 3 in the given integral equation on the right hand side. This portion, this is the right hand side portion. I am substituting pi of x is equal to 3. When pi of x is equal to 3 is a constant function, pi of xi is also 3. I am substituting pi of xi is equal to 3 in the right hand side. We have 0 to x x minus xi whole square into pi of xi dxi is equal to 0 to x x minus xi whole square into pi of xi means what? 3 into dxi. But from our knowledge of integrations, now you see, observe that 3 is constant outside of the integration, 0 to x x minus xi whole square into dxi. So integration with respect to xi, so f of x whole power n into f dash x. F of x whole power n into f dash x formula, look here, f of x whole power n into f dash x dx is equal to, answer is f of x whole to the power of n plus 1 by n plus 1. The scenario is, if a function f of x is there whose derivative is beside is there, then we can apply this formula. Now look here, x minus xi whole power 2 whose derivative is, I am writing 3 times of integral 0 to x x minus xi whole square. I am taking minus, here also minus 1. So dxi. So dxi. So see here, x minus xi power 2. So xi derivative is minus 1 with respect to xi. So f of x whole power n into f dash x. So we can use, so this formula is 3 times of minus already is there, minus of x minus xi whole power 2 plus 1, 3 by 3, 0 to x limits. ఓకే, ఇటు ఎందుకు ఇక్కడ మైనస్ వస్తుంది అంటే ఇక్కడ మైనస్ తీసుకోవడం వలన ఓకే అదేమైతుంది ప్లస్ అయిపోతుంది. అప్పుడు ఇది ఏ ఫామ్లో ఉంది, ఎఫ్ ఆఫ్ ఎక్స్ హోల్ పవర్ ఎన్ ఇంటూ ఎఫ్ డాష్ ఎక్స్ ఫామ్లో ఉంది కాబట్టి అప్పుడు ఈ స్ట్రక్చర్ వచ్చేస్తుంది. xi మైనస్ x minus xi whole power 2 plus 1 into 3 by 3 minus ఉంటుంది 0 to x. By using the fundamental theorem of calculus, upper limit minus lower limit. First I am going to substitute upper limit. Actually integration with respect to xi kabatti these are the limits are xi is equal to 0 to xi is equal to x. Now I am substituting xi is equal to x here, minus of 3 get cancelled, minus of I am substituting instead of xi is x minus x is 0, totally this becomes 0, minus fundamental theorem of calculus, upper limit minus lower limit x xi is equal to 0. I am substituting here x minus 0 whole cube x cube, therefore minus of minus plus x cube. So this equation RHS becomes what? X cube. Actually what is x cube? LHS. So RHS is equal to LHS. So that pi of x is equal to 3 is a solution of given integral equation which satisfies the given integral equation. So that we say that this is the solution of a given integral equation. Now next another problem is pi of x is equal to 1 plus x square whole power minus 3 by 2 is a solution of the Volterra integral equation. Pi of x is equal to 1 plus x square minus 0 to x xi by 1 plus x square pi of xi d xi. Here this is f of x. Here kernel k of x xi. Right? Now we are going to prove that the function pi of x is equal to 1 plus x square whole power minus 3 by 2 is a solution of this given integral equation. For that I am substituting pi of x in right hand side of the integral equation. Ila substitute chesanu. 1 by 1 plus x square 0 to x xi by 1 plus x square. Just I am substituting pi of xi value. What is pi of xi? Pi of x is equal to this one, pi of xi. Just replacing x by xi, we get 1 plus xi square whole power minus 3 by 2. Because substitution 1 plus xi square whole power minus 3 by 2 d xi, which is equal to 1 plus x square minus I multiply divided with 2 xi by 1 plus x square into 1 plus xi square whole power minus 3 by 2 d xi. So right, it is 1 plus x square is a constant, 1 plus x square because of integration with respect to xi kabatti 1 plus x square అనేది constant. అప్పుడు 1 by 1 plus x square ఎట్లా ఉంటుంది 1 by here already 2 ఉంది, ఇక్కడ 1 plus x square outside of the integration. So you observe here same formula here, f of x whole power n into f dash x. This is the f of x, 1 plus xi square whole power minus 3 by 2 means f of x whole power n whose derivative 1 plus xi square derivative 2 xi. సో ఎఫ్ ఆఫ్ ఎక్స్ హోల్ పవర్ ఎన్ ఇంటూ ఎఫ్ డాష్ ఎక్స్ ఫార్ములా అప్లై చేస్తే కనుక ఇది వచ్చేస్తుంది. దానికి లోయర్ లిమిట్ ఏది? xi ఈజ్ ఈక్వల్ టు 0, xi ఈజ్ ఈక్వల్ టు ఎక్స్. సబ్స్టిట్యూట్ చేసినట్లయితే 1 by 1 plus x square ఇంటూ 1 by 2 ఇంటూ 1 plus x square, అప్పర్ లిమిట్ xi ఈజ్ ఈక్వల్ టు ఎక్స్ ఐఎమ్ సబ్స్టిట్యూటింగ్. అప్పుడు ఏమవుతుంది? ఇది x square అవుతుంది. రైట్, అప్పర్ లిమిట్ మనము ఫస్ట్ ఐఎమ్ గోయింగ్ టు సింప్లిఫై దిస్. 1 plus xi square హోల్ పవర్ minus 3 by 2 plus 1 అంటే ఏమవుతుంది? minus 3 plus 1 by 2 1 by 2 అవుతుంది. by minus 3 by 2 plus 1 means 1 by 2. It is minus 1 by 2 by 1 by 2. 1 by 2 కాస్త రివర్స్ అయితే ఏమవుతుంది? 2 by 1 అవుతుంది. minus 2 by 1. 2 get cancel. So 1 by 1 plus x square minus of minus plus 1 by 1 plus x square. Now I am applying upper limit is xi is equal to x, lower limit xi is equal to 0. I get 1 by 1 plus x square whole power 1 by 2. Xi is equal to 0 means 1 plus 0 means 1. After simplifying we get this result. So that means what? 1 plus x square whole power minus 3 by 2. It is the what? LHS. LHS means pi of x. LHS means pi of x. RHS is equal to RHS తీసుకుంటే మనకి ఏమొచ్చింది? ఈ ఫంక్షన్ వచ్చింది. ఈ ఫంక్షన్ ఏంటిది? LHS. LHS means pi of x. Pi of x value 1 plus x square whole power minus 3 by 2. So LHS is equal to RHS. Therefore pi of x is a suitable solution for this integral equation. See one more example. Show that the function pi of x is equal to 1 by pi root x is a solution of the integral equation. Sir, for this integral equation we are going to check this pi of x is equal to 1 by pi root x is a solution or not. I am checking. Same I am taking in the LHS is in the left hand side 0 to x pi of xi by root x minus xi d xi is equal to 1. I am substituting this pi of xi value in left hand side. LHS 0 to x. Just what is pi of xi? 1 by pi root xi by root x minus xi d xi. 1 by pi outside of the outside of the integral, because of it is an integral, it is a constant for that outside of the integration, which is the one of the linear property for integrations. So I can multiply root xi into root x minus xi. So xi x in minus xi square 1 by pi into 0 to x. I can convert this into one perfect square. I want to convert this as a perfect square, and that means what? X square that means x minus alpha whole square plus beta square, or x minus alpha whole square minus beta square, or beta square minus x minus alpha whole square లోకి దీన్ని కన్వర్ట్ చేస్తున్నా. రూట్లో ఉన్న టర్మ్ని అట్లా కన్వర్ట్ చేసుకోవాలి. ఎందుకంటే మనకు 1/√a square minus x square, 1/√x square minus a square, 1/√x square plus a square ఫార్ములాలోకి కన్వర్ట్ చేస్తున్నాం. అప్పుడు 1/5 ఇంటూ రూట్ ఆఫ్ ఇంటిగ్రేషన్ 0 to x, అప్పుడు మైనస్ కామన్ ఇస్తుంది. బికాస్ ఆఫ్ xi square coefficient is minus, ఐఎమ్ టేకింగ్ మైనస్ కామన్ ఎంటైర్. So xi square minus xi plus x square by 4. Yeah, this is here add and subtract x square by 4. So I am writing this is like this. This becomes, it is a perfect square. I can write this is what we call x minus xi minus x by 2 whole square. So x square by 4. X square by 4, it is what? Xi minus x by 2 whole square. Already here minus. So this is plus x by 2 whole square minus xi minus x by 2 whole square into d xi. Is clear? సో ఇది పర్ఫెక్ట్ స్క్వేర్లోకి మార్చుకున్నాడు. అప్పుడు ఏమైంది, ఇది xi మైనస్ ఎక్స్ బై 2 హోల్ స్క్వేర్, ఇది మైనస్ ఇది ప్లస్ కావడం వల్ల ప్లస్ ఫస్ట్ రాసి సెకండ్ మైనస్ రాస్తాడు. సో ఇదే ఫార్ములా ఉంది. యాక్చువల్ ఇంటిగ్రేషన్ విత్ రెస్పెక్ట్ టు xi కాబట్టి x కాన్స్టెంట్. సో a స్క్వేర్ మైనస్ x స్క్వేర్ మోడల్ ఉంది. ఇన్ ద ఫార్మ్ ఆఫ్ a స్క్వేర్ మైనస్ x స్క్వేర్. వాట్ ఇస్ ద ఇంటిగ్రేషన్ ఆఫ్ a స్క్వేర్ మైనస్ x స్క్వేర్ dx? 1/a sin inverse of x by a. For that already 1/pi is there. 1/a means x by 2, 1/x by 2 sin inverse of xi minus x by 2 by x by 2, 0 to x limits. 1/a sin inverse of x by a. So 1/5, it becomes 2/x. Then apply the upper limit first and then lower limit. We get, so sin inverse of 1. That means what? Sin inverse of 1 means pi by 2. So similarly we get also this minus pi by 2, minus of minus plus pi by 2. So 1/pi into pi by 2 plus pi by 2 is equal to, this means 2 pi by 2 means pi get cancelled, this value is equal to 1. Then what is in RHS? 1. Therefore left hand side is equal to right hand side. LHS is equal to RHS. Then pi of x is equal to 1/pi root x is a suitable solution or correct solution for given Volterra integral equation. And also we saw, you maybe try to solve this problem. It is in textbook. And also we have, this is a CSIR question in previously. Show that the function pi of x is equal to x e power x is the solution of the Volterra integral equation. Pi of x is equal to sin x plus 2 times of 0 to x cos of x minus t into pi of t dt. xi place లో ఇక్కడ t తీసుకున్నాడు కాబట్టి అప్పుడు ఇంటిగ్రేషన్ విత్ రెస్పెక్ట్ టు t అన్నాడు. ఓకే, జస్ట్ చేంజ్ ఇది. సో కెర్నల్ ఈజ్ ఈక్వల్ టు kernel. What is the kernel here? Cos of x minus t is the kernel. Pi of is unknown function. Pi is an unknown function. Sin x is f of x. So try to solve this problem in the similar manner. Now here Leibniz rule for differentiation under the integral sign. Leibniz rule for differentiation under the integral sign. Here we have two concepts for a single variable and two variables. Suppose it is a two variable function. Integral function in two variables. I want to differentiation this function with respect to alpha. So d by d alpha of this function is equal to this is called as a differentiation under the integral sign. Differentiation under the integral sign. That means what? Dou by integral a to b, dou by dou alpha of f of x alpha. Dou by dou alpha of inner function is f of x alpha dx, where a, b are the constants of integration. When a and b are the constant of integration, we write directly this one. It is a two variable function. Even though it is a two variable function, when a and b are the constant, directly the it will comes under the integral sign. It is a d, it is a dou, right? Whereas lower and upper limits are functions. The derivative of an integral function is like this. So the lower limit is p of x, upper limit is q of x. These are the y limits. Y is equal to p2, y is equal to q of x. So function is f of xy. So Leibniz rule is d by dx of this is equal to, so integration of p of x to q of x, f of means dou by dou x of f of x. అంటే f ని పార్షియల్ డిఫరెన్షియేట్ చేయాలి. f పార్షియల్ డెరివేటివ్ విత్ రెస్పెక్ట్ టు x dy ప్లస్ ఏం చేయబోతున్నామంటే, ఇన్స్టెడ్ ఆఫ్ y I am writing pi of x. Instead of y I am writing pi of x. F of x pi of or q of x. F of x q of x, because of y is equal to q of x. F of x q of x into differentiation of upper limits minus same scenario lower limit, replacing y by p of x, f of x p of x into differentiating upper limits. This is called as a Leibniz formula for two variables. I repeat once again, d by dx ఇవి రెండు చాలా ఇంపార్టెంట్ అండి. మీరు గుర్తుపెట్టుకోవాల్సిన అవసరం ఉంటుంది. ఫర్ డిఫరెన్షియేషన్ ఆఫ్ ఏ ఫంక్షన్ అండర్ ద ఇంటిగ్రల్ సైన్ ఒక థీరం ఉంది, దానికోసం ఖచ్చితంగా మనం ఇది గుర్తుపెట్టుకోవాల్సిన అవసరం ఉంటుంది. సో d/dx ఆఫ్ మీకు ఇది డిఫరెన్షియల్ ఈక్వేషన్స్లో కూడా వస్తుంది, రైట్. సో వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ దీస్ టూ? ఇట్ ఈస్ బోత్ లోయర్ అండ్ అప్పర్ లిమిట్స్ ఆర్ కాన్స్టెంట్, దిస్ ఈజ్ హోల్డ్స్. If the function lower and upper limits are functions, then this is holds, right. Now I am explaining differentiation of a function under the integral sign. So here, look here, Inx is equal to this, look like the reduction formulas like that. If Inx is equal to integral a to x x minus xi whole power n minus 1 f of xi dxi, then Inx is equal to n minus 1 into n minus 1 factorial times of a to x integral a to xn integral a to xn minus 1 and so on integral a to x2 f of x1 dx1 dx2 and so on dxn. This is the result or theorem. For proving of this theorem, let f of xi kernel is equal to, here this is the kernel f of xi. So k f of x not kernel, I am taking this entire function f of xi is equal to x minus xi whole power n minus 1 into f of xi. So then Inx is equal to integral a to x given function f of xi dxi. I am taking this function is capital F. So then Inx becomes like this. Now I want to differentiating this one. In dash means what? Differentiating above equation. So but upper limit is variable function, lower limit is constant. By using this formula, by using Leibniz formula, I get like this. Then the derivative of this function In is equal to this one. That means integral a to x f of x by n minus 1 f of xi is equal to this one. What is f of xi? This function. I can apply UV method. We get this function. So n minus 1 is constant outside of the integration. A to x x minus a whole power n minus 2 into f of xi dxi. Then using integrations, then we get din by dx is equal to n minus 1 into it is denoted by In is equal to look like it is denoted n minus 1. In minus 1 means what? N minus 1 minus 1 means n minus 2. It is denoted by In minus 1, right? For that, so again differentiating this, we get first differentiation is n minus 1 into In minus 1 of x. Again differentiating this, we get n minus 1 into n minus 2 In minus 2 of x. Two times. First times n minus 1, 2 times n minus 2, n times I am differentiating this, I get n minus 1, n minus 2, n minus 3 and so on, 2, 1 like that, n minus 1 factorial I1x, n minus 1 factorial into I1x. After here again I want to differentiating d power n minus 1 by dn power, I want to differentiating this function with respect to one time, that means this one, this is equal to n minus 1 into di1 by dx. So already differentiating n minus 1 times. Already differentiating n minus 1 times. Here one time, total number of times differentiation is n times. So d power n by dx power n of In is equal to n minus 1 factorial of di1 by dx. These are the classification or differentiation of a function under the integral sign procedure. So we get Inx is equal to this one. So I1x is equal to integral e to x f of xi dxi. Now I want to differentiating this function. I1 dash x is equal to same using Leibniz formula. So that from equation 1 we get d power n y by d power n in by dx power n is equal to n minus 1 factorial of f of x, because of I1 dash x value. I1 dash x is equal to what? Here I1 dash x means di1 by dx. Our value ento vachindi manaki ikkada f of x vachindi. Now I am substituting this value in equation 1. We get d to the power in y by dxy is equal to this one. So it is nth order differentiation of In. Now integrating equation 2 with respect to x between the limits a to x n minus n times. Now I want to integrating this equation n times with respect to x between the limits a to x. We get Inx is equal to, because of I am integrating this n times, for that n will be cancelled, because of integration is the inverse process of differentiation. D power n by dx power n goes to only, we get only In. Then n minus 1 factorial integral a to x because of how many times here? N times a to x, a to xn, a to xn minus 1 and so on, a to x2, x2, x3, x4, x5, xn including x, total number of times is n times f of x1 dx1 dx2 and so on dxn. N times integrating we get this one. This is the formula for differentiation of under the integral sign Inx is equal to this one. Now given Inx is also written as like this, right? Now remember these 2 points, integration of a to x, a to x1, a to xn minus 1 and so on, a to x2, f of x1 dx1 dx2 and so on dxn is denoted by this symbol a to x f of z dxi power n. Because of integration with respect to n times, so it is also denoted by a to x f of xi dxi power n, which is also equal to Inx value from equation 3. This is equal to what? Inx. Inx means what? 1 by n minus 1 factorial integral a to x, x minus xi whole power n minus 1 f of xi dxi. These are the formula. A to x f of z dxi power n is equal to 1 by n minus 1 factorial a to x f x minus xi whole power n minus 1 into f of xi dxi. ఈ ఫార్ములా మనకు ప్రాబ్లమ్స్లో ఉపయోగపడుతుంది. అంటే అర్థం ఏంటిది? దిస్ ఇంటిగ్రల్ ఈక్వేషన్ ఈజ్ ఈక్వల్ టు డైరెక్ట్లీ ఐఎమ్ రైటింగ్ 1 by n minus 1 factorial of a to x, x minus xi whole power n minus 1 into f of xi dxi, which is denoted by what? a to x f of xi dxi power n. చూడండి, a to x f of z dxi power n అంటే మనం ఏం రాసుకోవచ్చు అంటే 1 by n minus 1 factorial, ఇక్కడ n బేస్ చేసుకుని ఉంటుంది, 1 by n minus 1 factorial 1 by n minus 1 factorial a to x xi minus whole power n minus 1 into f of xi dxi. Suppose, so it is useful for conversion of linear differential equations into integral equation. This formula is useful for conversion of linear differential equation into integral equation. For example, I am taking what integral a to x f of xi d xi cube కావాలనుకోండి. అప్పుడు ఏంటిది? ఇక్కడ n is equal to 3. According to our formula, 1 by n minus 1 factorial 3 minus 1 factorial integral a to x x minus xi whole power n minus 1 3 minus 1 into f of xi dxi. This is the formula, right? For example, integral a to x f of xi dxi power 10 వచ్చింది అనుకోండి, 10 times integration. That means what? 1 by 10 minus 1 factorial integration of a to x x minus xi whole power 10 minus 1 f of xi dxi. So this formula is useful for such type of integrations. So it will be very useful in conversion of linear differential equation into integral equations. Next, the relation between linear differential equation and integral equation. Relation between linear differential equation and integral differential equation. So, for example, consider the linear differential equation of nth order. This is the linear nth order differential equation. We know in a differential equation we consider is the linear nth order differential equation whose coefficients are the functions. a1x, a2x, a3x are the functions in terms of x with initial conditions are y of 0 is equal to c0, its derivative at 0 is c1, double derivative is c2 and so on cn minus 1. For solving of this differential equation, linear differential equation, we can take nth derivative d power ny by dx power n is equal to some function pi of x. మరి దీన్ని ఎట్లా సాల్వ్ చేస్తారంటే అందులో హైయెస్ట్ డెరివేటివ్ ఫంక్షన్ ఏదైతే ఉందో దాన్ని పై ఆఫ్ ఎక్స్ అనుకోవాలి. ఓకే, సో ఇప్పుడు దీన్ని ఏం చేస్తూ పోవాలి అంటే ఇంటిగ్రేషన్ చేస్తూ ఉండాలి. అందుకు హైయెస్ట్ డెరివేటివ్ని పై ఆఫ్ ఎక్స్ అనుకున్నా కాబట్టి నాకు ఏం కావాలి? నెక్స్ట్ dn minus 1 by dx power n minus 1 కావాలంటే ఇంటిగ్రేషన్ 1 టైం చేస్తే ఇది వస్తుంది, 2 టైం చేసి ఇది వస్తుంది, 3 టైం చేసి ఇది వస్తుంది. ఈ విధంగా ఇంటిగ్రేషన్ చేస్తూ మనం ఏ వాల్యూస్ ఇవన్నీ క్యాలిక్యులేట్ చేసి వీటిని సబ్స్టిట్యూట్ చేసుకున్నట్లయితే అప్పుడు ఈక్వేషన్ కాస్త కన్వర్ట్ అయిపోతుంది. ఓకే, సో పై d power n by dx power n is equal to pi of x అనుకోవాలి. తర్వాత దీన్ని ఇంటిగ్రేషన్ విత్ రెస్పెక్ట్ టు x బిట్వీన్ ద లిమిట్స్ 0 to x we get d power n minus 1 by dx power n minus 1. ఇంటిగ్రేషన్ ఒకసారి చేసినప్పుడు ఒకటి తగ్గిపోతుంది. విత్ ఇన్ ద లిమిట్స్ 0 to x రైట్ హ్యాండ్ సైడ్ 0 to x pi of t dt. మళ్ళీ అగైన్ ఇంటిగ్రేషన్ చేసుకుంటూ పోతూ ఉంటే మనకి ఏమొస్తుందంటే ఇక్కడ ఈక్వేషన్స్ అన్నీ పై మీన్స్ వాట్ d power n minus 1 dx power n minus 1, d power n minus 2 by dx power n minus 2 ఆల్ ద వాల్యూస్ మనకి ఇక్కడ వస్తాయి. ఇవన్నీ తీసుకుపోయి ఇచ్చిన డిఫరెన్షియల్ ఈక్వేషన్లో సబ్స్టిట్యూట్ చేయాలి. దాన్ని డీటెయిల్స్గా పోకుండా మీకు నేను ఒక ఎగ్జాంపుల్ ప్రాబ్లం ఇస్తున్నాను. సీ దిస్ ఎగ్జాంపుల్ ప్రాబ్లం. ఇది మనకు టెక్స్ట్ బుక్లో మెటీరియల్లో కూడా ఉన్నది. మీరు ఒకసారి అబ్జర్వ్ చేస్తే ఈ క్వశ్చన్స్ కూడా మీకు దొరుకుతూ ఉంటాయి. సీ దిస్ ఎగ్జాంపుల్. form an integral corresponding to the differential equation, this one. అంటే ఈ డిఫరెన్షియల్ ఈక్వేషన్ నుంచి నేను ఇంటిగ్రల్ ఈక్వేషన్ని ఫైండ్ అవుట్ చేయాలి. చూడండి, what the beauty of this mathematics. Now I can convert the differential equation to an integral equation by using the method of substitution. So see here, these two are the boundary conditions. Y double dash minus 5y dash plus 6y is equal to 0. Highest derivative is y double dash. Put y double dash d square by x square equal to pi of x. Now integrating this with respect to x, taking the limits 0 to x, y double dash ని ఇంటిగ్రేషన్ చేస్తే ఒక టైం డెరివేటివ్ క్యాన్సిల్ అయిపోతుంది. అప్పుడు ఏమొస్తుంది మనకు y dash of function y r dash within the limits is 0 to x. రైట్ హ్యాండ్ సైడ్ 0 to x pi of x dx రాయొచ్చు, pi of xi dxi. 0 to x pi of x dx బదులు 0 to x తీసుకున్నాం కాబట్టి pi of xi dxi, it is a dummy variable property. We can write this way also, correct way. So then y dash of upper limit is x minus y dash of lower limit is 0. We get right hand side 0 to x pi of xi into dxi. Therefore y dash of x minus y dash of 0, initial value condition y dash of 0 is equal to -1. So this is equal to this one. Now y dash of x is equal to 0 to x pi of z dz. This plus 1 becomes this side, this is -1. Now this is equation 2. Now again integrating, because of highest derivative is y double dash. Here highest derivative is y double dash. We can integrating twice, 2 times. So again integrating 0 to x with respect to x. Then this y double dash goes to y within the limits 0 to x. Integral 0 to x, already again 0 to x pi of xi dxi square. Dxi into dxi, this can be denoted by dxi square. Then again minus of this 1 dx means 0 to x 1 integration of xi. So upper limit is x, y of x minus lower limit is 0, y of 0 is equal to 2 times of integration according to previous note 1, note 2. If 2 times of integration, I can write like this: 0 to x pi of xi dxi square. 0 to x pi of xi dxi square. This means 0 to x pi of xi dxi square means x minus xi whole power 2 minus 1 by 2 minus 1 factorial into pi of xi dxi. In the previous concept, మనం ఎంతమంది ఏం రాస్తాము, ఇంటిగ్రల్ 0 to x pi of xi dxi square is equal to pi of xi dxi square is equal to, we can write like this: 1 by 2, n is equal to 2 minus 1 factorial, n is equal to 2 minus 1 factorial. Integration of 0 to x minus xi whole power 2 minus 1 pi of xi dxi. Same scenario you can apply here. We get this function. So y of x minus 0 is equal to integral 0 to x minus xi into pi of xi into dxi minus x dx. So y of x is equal to, so this is the formula. So this the value is y of x, this is y dash x, it is y double dash x. Substituting y double dash and y dash and y of x in the given differential equation. So substituting these values in the given differential equation, we get, so this is the y of x, pi of x minus, so pi times of this plus 6 times of this is equal to 0. After simplifying this equation, I get like this. So it is the required integral equation, which is is small f of x. It is the kernel function. So here kernel k of xi is equal to 5 minus 6x plus 6xi. So f of x, capital F of x is equal to, here this function is 6x minus 5. So it is the integral equation, right? So this is also important method. సో దిస్ ఈజ్ హియర్, ఇక్కడ మనం అనుకోవాల్సింది ఏంటంటే హైయెస్ట్ డెరివేటివ్ ఫంక్షన్ ఏదైతే ఉందో దాన్ని మనం పై ఆఫ్ ఎక్స్ అనుకొని, ఇక్కడ హైయెస్ట్ డెరివేటివ్ ఫంక్షన్ వై డబుల్ డాష్ కాబట్టి 2 టైమ్స్ కనుక ఇంటిగ్రేషన్ చేస్తే మనకు వై డాష్ వస్తుంది, ఇంకోటి వై వస్తుంది. ఇవి తీసుకుపోయి అందులో సబ్స్టిట్యూట్ చేసిన ఇక్కడ ఈక్వేషన్ 1లో సబ్స్టిట్యూట్ చేయాలి. గివెన్ డిఫరెన్షియల్ ఈక్వేషన్లో సబ్స్టిట్యూట్ చేస్తే వై డబుల్ డాష్ నీకు ఇక్కడ వై డబుల్ డాష్ వై డాష్ అండ్ 6yని ఇక్కడ సబ్స్టిట్యూట్ చేసినట్టయితే ఈక్వేషన్ ఇలా సింప్లిఫై అవుతుంది. సో దీన్ని మనం ఇలా కన్వర్ట్ చేసుకున్నట్లయితే దీన్ని ఏమంటామంటే ఇంటిగ్రల్ ఈక్వేషన్ అంటాము. ఇన్ దిస్ ఇంటిగ్రల్ ఈక్వేషన్ కెర్నల్ ఈజ్ ఈక్వల్ దిస్ వన్, ఇది ఎఫ్ ఆఫ్ ఎక్స్. సో దిస్ ఈజ్ ఫస్ట్ కైండ్ ఆర్ second kind of Fredholm integral equation, because of whose upper limit is x variable, x, so that it is a Fredholm integral equation of first kind. So thank you very much for watching this video, and also you can solve similar model problems. You see, I'm giving one more problem for you. This is Form an integral equation corresponding to differential equation y double dash plus xy dash plus y is equal to 0. So initial conditions are this one, right? So I am giving this solution is here. Please find the complete solution of this equation. Due to time factor, I am not giving details. Same model problem. This is the same model problem. You may try yourself also. Check your progress. This is the problem for check your progress. Thank you.